One of the many things you can do with exponential models is age, date, different materials like dinosaur bones and different substances that you might find in the ground using this thing called carbon-14 dating. And I have a pretty simple question here. Right out of a textbook, it says archaeologists use carbon-14, which has a half-life of 5,730 years, to determine the age of artifacts. Write the exponential decay function for a 24 milligram sample, and then determine how much carbon-14 remains after 30 millennia. 30 millennia, 30 times 1,000 is 30,000 years. So a couple things to determine right off the bat. When we're dealing with a half-life, that is an R value of negative 50%. It means every, in this case, 5,730 years, we diminish the sample by 50%. So let's go ahead and start putting everything into our formula. Now the formula that I'm going to work from is going to be the same formula that you've probably learned many times. It looks like this. The values for each one of these are going to be the total amount of stuff in this many time periods. This t and this t are the same. This is how much stuff we begin with, and this is the rate of decay or growth, but in this case it's decay. So let's go ahead and do this, right? So I have, I don't know how much, from a 24 milligram sample, and we have a half-life of negative 0.5 because it's declining by 50%, so negative 0.5. And the time period is, now I'm going to help you on the time period. It tells us that it was, buried or unearthed 30 millennia after it was buried. So 30 millennia is 30,000 years, and the time period that we're working from is this. Where'd it go? Here it is. So 5,730. So how many 5,730s are in 30,000? Well, I don't know. Let's figure it out. So let's go ahead and do 30,000 divided by 5,000. There we go. 5,730. So we have 5.24, let's say. So 5.24. So 5.24 is the number of time periods. So that's going to be our exponent, 5.24. So zoom in. And at this point, really, this is just a calculator task. It's 24 to the 0.5, sorry, with a base of 0.5 to the 5.24. A quick little note here, when you're doing this problem, be careful that you do the exponent piece first, and then you do the times 24. Sometimes that can throw you off, depending on how your calculator functions. So I'm going to go ahead and clear, do 0.5 raised to the 5.24 power, and I get that number, and I'm going to multiply that by 24, which is the original amount of the sample, and I have 0.64 milligrams of carbon-14 remaining. Right? That's the idea. Yeah.